representing aqueous reactions. So the types of equations that we've been writing so far are what are called molecular equations. These show the complete formulas for each compound as if they existed as molecules. But we've been talking about solutions, and we know that if an ionic compound is dissolved in water, that it actually separates into the ions. And so a molecular equation is not representing what's actually going on very well. So here's an example. Potassium hydroxide and magnesium nitrate. They're going to react and form potassium nitrate and magnesium hydroxide. This is going to precipitate as a solid, but this potassium nitrate, those ions are still going to be separate, moving around in solution. So the complete ionic equation shows all of the species as they're actually present. And so these aqueous substances are actually separated into ions, and so in the complete ionic equation, we separate them into ions. And then the net ionic equation shows only those things that actually change, that are involved in the reaction. Here, potassium went to the party, and, after the party's been going on, potassium's still just mingling around. He did not find his soulmate. But magnesium and hydroxide got entangled in each other. They got involved, right? They were changed. And so the net ionic equation just shows the things that are changed. It's a little bit like your net paycheck as opposed to your gross salary. Your net salary is after they take out all the stuff for taxes. So when we write complete ionic equations, any aqueous ionic compounds get written as ions. We separate them and we write their formulas with their charges. So this includes soluble salts, strong acids, and strong bases. So I gave you that list. There are 6 strong acids. We recognize acids as starting with H. So if it's on that list, you separate it, otherwise you don't. If you have a solid, a liquid, or a gas, you just leave it alone. You don't separate it. So if the state symbol is aqueous, there's a good chance you're going to separate it into ions. If it's solid, liquid, or gas, you do not. The one thing you have to watch out for is that weak acids will have AQ as their state symbol, but they're always written in molecular form because they only form a few ions. Mostly they are the molecule. So here's an example of lead nitrate and potassium chloride. Lead nitrate is a soluble ionic compound, and so we separate it into ions and write them separately, lead 2+ and 2 nitrate ions. And KCl is a soluble ionic compound. We write K+, aqueous, and Cl- aqueous. The 2's here come because there are 2 units of KCl in this equation. Lead chloride is a solid, and so we just copy it down. You don't change it at all. If it says solid, liquid, or gas, don't do anything. And here we have another aqueous ionic compound. And so we're going to separate it and show the 2K+ and the 2NO3-. Any questions? This is the complete ionic equation. Now look at that complete ionic equation, and can you find an ion that does not get changed? Potassium. So 2 potassium ions here, aqueous, and at the end, 2 potassium ions. Those are called spectator ions. They came and they watched. They watched lead and chloride get it on the back porch, but they didn't participate, okay? So when we write the net ionic equation, we get rid of those. Because lead and chloride would have gotten together even if chloride had come with sodium, right? It was just important that chloride get there. The fact that potassium was there had really nothing to do with it. What's another ion that didn't change? The nitrate. Pardon the mooing, it's the balance is self-calibrating. When we cross those guys off, we get the net ionic equation that just tells us the things that are actually changed.
So the insoluble is the weak acids, all of this you write as molecules as well?
You write weak acids as molecules, yeah. So here we show the same complete ionic equation, but with the spectators crossed out. Because think about a boxing match. You know, you go to a boxing match and you sit in the stands, you're a spectator, right? You're watching the guys boxing. Do you go home with a black eye and a bloody nose? Not unless things got really out of control at the boxing match, right? Usually the people in the stands leave in the same condition that they came. They were spectators. So the net ionic equation, we're just looking at the people in the boxing ring or the people in the love relationship or whatever it is they're doing. The spectators don't really matter. The action was what was in the ring. Any questions? Let's do an example. Consider the following reaction occurring in aqueous solution. 2HI plus BaOH2 yielding 2H2O BiI2. It says write the complete ionic and net ionic equations for this reaction. When you're starting out, you need to write the complete ionic equation before you can write the net ionic equation. Later, you might be able to skip that. But for now, you got to do the complete ionic equation first. So we are going to look at each of these species. Here, this is aqueous. So we're probably going to break it into ions, but we need to be careful because this is an acid. Is HI a strong acid? Yeah, it's one of those 6. So HI is a strong acid. Strong acids dissociate completely, and so we're going to write it as ions. So we've got 2H plus aqueous plus 2I minus aqueous. You have to include the charges, and there were 2 of those molecules, and so we're going to get 2 of each of the ions. Then we look at the next one, barium hydroxide. Bless you. This is aqueous. It's not an acid, so we're definitely going to separate it into ions. So the first ion is barium, Ba2 plus, aqueous. And then we've got OH2. This is the shrink wrap, the parentheses, and the 2 is telling us I have 2 of those units. When this dissolves, those 2 units can go their separate ways. And so this is 2 OH minus ions, 2 hydroxide ions. And that brings us to the arrow. Water has the state liquid. If it's a liquid, solid, or a gas, just copy it down. Do not separate it into ions. So I'm just going to copy that one as is. And then I've got barium iodide, aqueous, soluble ionic compound. So I'm going to write that as individual ions. A barium ion, and 2 iodide ions. Any questions? If you did everything correctly, carrying through these coefficients and subscripts, you know, allowing that there's 2 of those, it should be balanced. Probably a good idea to check that. So that's the complete ionic equation. To write the net ionic equation, we're just going to get rid of the spectators. Pardon me?
So you're just going to write the ones that react?
We're just going to write the ones that actually react. The most straightforward way to do this is to just cross the spectators out and write down what's left. And so we'll look here, H plus, no, there's not an H plus on that side. 2I minus and 2I minus, so those are spectators. And then barium is present on both sides, and so take those out. And then we've got the OH minus, there's no OH minus on the other side. So I'm going to take these and write 2H plus aqueous plus 2 OH minus aqueous forms 2 H2O liquid. Now what's a little funny about that equation? Is it balanced? It is balanced, but it's not the lowest coefficients. And usually we want the lowest coefficients. We could divide each of these coefficients by 2, right? So we're just going to get rid of those. And that's the net ionic equation. Any questions?
So if you were to boil that product, would you get barium and iodine left over?
Yeah. If you took this solution and you boiled all the water away, you would be left with barium iodide. And they would combine in an ionic compound, and you'd see this crystalline salt left. Any other questions? The result of doing that would be the same as if you took barium iodide itself and put it in some water and boiled off the water. You'd get the barium iodide back.